Hello everyone, and welcome to my talk. I want to tell you today about how to build great offline first apps. And before I start, I want to introduce you to my friend, Ralph, the raccoon, who will help me today. And his favorite part-time or hobby is to pull power plugs. And especially power plugs from servers or network hardware or whatever. And his catchphrase is then normally, "Look, mom, no internet." And how you can become friends with Ralph, because we don't have a grudge anymore. I hope at the end of the talk you will also become friends with him or know how you can become friends. So, who is on call today or on pager duty or anything the likes? Looks like Ralph was busy this morning, so all the people on pager duty fixing their things because he switched them off. So let's explore why we should do offline first. And there's a few things to it. Like a big topic is UX, the user experience. Can benefit a lot if your app can handle the offline case. I'm in Germany, for example, often taking the train to different locations, and their app of a big train service provider has a very complex checkout process. Like you select the train you want to take, you will select a payment method that you want to use, you select the seat you want to have, and I think it has 6-7 pages that you go through. And whenever there is no internet in this process, you see, oh, something went wrong, please retry. And if you click the retry button, you go back to the start and do the whole process again. And that is, of course, great UX, and everybody loves using that app. So yeah, that's maybe not what you should build. But also there's more subtle things to UX. For example, also taking you again to Germany, a supermarket. We don't have these self-checkouts that frequently that you have here in the UK. But we have these cashiers that scan the items for you. And there's a small competition going on. Like the cashier that scans and you packing the goods, and they're quite fierce. Like it goes beep, 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 and you're like, pack, pack, pack. And like the people already behind you, oh, he's not keeping up. And then you're already back with 3 items. And then they ask you, oh, you also have a loyalty card. And you're like, yeah. And then get out the phone, you open your loyalty card app, you see a loading spinner, people already standing behind you, and like, oh, what is taking so long? Then you select the card you want to show, loading spinner again, people already, what is going on there? And finally you scan your card, and of course this user will also not use your app if you build a loyalty card app, because they next time will bring their plastic card, they can just whip out and scan again. So that is like definitely improvements to UX, but also the developer experience can benefit from building an offline first app. We will explore later, like how awesome is it if you build a UX flow and you don't care about network errors. Like that was a great experience for me the first time. And also on cost, like if you have an app that barely talks to the servers, you need much less servers. And if you think about it, the most cost for the companies we work at is normally the people, the engineers, and the servers that they're running. And so it's better to cut back and save on the servers, so we can go to droidcon and spend the money on the good things. And also the last point is it's not super complex. So it's not like rocket science. And I think everybody can invest there and build a better experience also offline first. To explore that, I want to talk to you about a use case that we build maybe together here, not really, but we pretend. And that is about digitizing such a loyalty card. So these things like have a barcode on it, and you scan them to collect some points at the checkout. And how would you build that? So let's say we sit together with our PM, with our designer, and we come up with a great flow for the user to digitize one of these. And let's say it starts with a screen where the user can decide to add his card. So also where later the cards will show up, there's a big button that says add your card. The user clicks on it. Then another screen pops up where we can select, because there's quite a diverse set of loyalty programs out there. And you can select, for example, Boots or whatever you want to have. And once the user selected the program that you want to have, a scanner pops up where we can scan the barcode from the card. And last, when the barcode is scanned, we have it in the app. So great, looks like a great UX flow. But actually, we are lying there to ourselves, and we do that every day, because that's not actually what we are building. That's what we are planning, but what we are building looks quite different. because once the user clicks the add card button, what is the app doing? Talking to the server to fetch the list of loyalty programs. So there's another screen in between that is a nice loading spinner for maybe 1, 2, maybe 5 seconds, depends where you are, how big the list is. Then once we select the loyalty program, we need to fetch again something from the server to figure out how we should scan it. So now another nice loading spinner, user waits. And once the card is scanned, we need to send the result to the server. And of course, you have another nice loading spinner and waiting and waiting. And that is actually the happy case. And the unhappy case is still the threadful, something went wrong, please retry. And if you have implemented it very nicely, user goes back to square one and doesn't start in the screen before. So let's also talk about it, like how it looks behind the scene, behind the UI. And there's like the user clicks something or interacts with the app. The app then sends something to the backend, and we get a reply from the backend to the app, which then represents it or shows it again to the user. And now keep in mind, on Android, we always have to, after 16 milliseconds, after there was something, we should react to it to have a smooth app. And if you think about it, app to backend, that takes like 2, maybe 5 seconds. So nowhere close to the 60 milliseconds. So we have to have a loading spinner in there, in between, to show the user something is happening. And that is actually also not really a real representation of the thing, and we should put it more like that. That the app is much further away, because the user interaction with the app is quite quick. And that's still not really true. I only run out of slide. I should maybe put it somewhere over here to be really accurate. And another thing also is, like, if you think about if you're using an app, you have the phone in your hand, you click it. How often did it happen that the phone just disappeared, was gone, like poof? Never, right? That's a really fringe case. But with the backend, that actually can happen, because yeah, you go through a tunnel, like the route is very unclear where your communication goes over between app and backend. So this we have to also keep in mind when we're building things. How nice would it be to build an app that interacts with the user directly without talking to the backend? And this communication would be decoupled and not directly part of each user flow. So like more or less that user talks to the app locally on the phone, and then the app talks to the backend whenever it works, when there is this kind of crazy maze aligning that it can talk to the backend. So this is more or less what we decided at Stokart, how we built our app and how we think about our app, and that is more or less what I want to tell to you, how we arrived there and yeah, how we're doing these things nowadays. So let me take you on a journey with the Stokart app, but I haven't introduced myself yet, so let's start with that first. Yeah, I'm Andreas. I'm working on Stokart now for 9 years. We are now part of the Klarna universe, and yeah, the Stokart app is loyalty cards, as you might have noticed, but not only, but like we built a mobile wallet, and loyalty cards is one big feature of it, but we will explore more of that on the go. So let's take you back to 9 years when I just graduated from university, started to look for my first job, became an Android engineer, and I call that the act number 1, the golden age, because it is the age of apps that are offline only, so not offline first, but there were apps that like didn't even have the permission to access the internet. Crazy to think about it, but yeah, that happened. Also the age of spaghetti code in one activity where everything happened, but we have solutions for that on a separate track. So back then, this was my team. So there was Hugo running HR, there was Ida building the iOS app, me building the Android app, and Betty running all the business things. So if you think now, if you would be part of that team, who would you, or if you are Hugo HR, who would you have hired additionally to that? Any ideas?
Designer?
Sorry? Designer is also good? Yes, yes. Yeah, actually the first one, engineer did that on the side for us, so we didn't have a designer in the first one. But yeah, any other ideas? Very good. I heard backend engineer somewhere. So yeah, exactly. Nowadays, we would definitely hire a backend engineer for that. But actually, that worked quite well for a year or two to have. Of course, we had somebody building a homepage or things, but the app was really offline only, so nothing with a backend. And yeah, that worked great. And the model was then more or less like user interacts with the app, app talks to a database locally where we store all our data and show it to the user. So if there was no internet, we didn't care. If the backend was off, we didn't have a backend, so can be off all the day. We don't care. And yeah, at one point we noticed like our app, not only our parents used it, but also other people on the street actually started using it. And we thought like, wouldn't it be awesome to also earn some money with that? So we thought like, what could we build to make that work? And we came up, it would be great to have some offers, like the latest deals, the flyers of the week, where users can inform themselves. But it's also not just like banner ads or something, but tailored to your location, also tailored to the loyalty cards you have, and a lot of other things. So it's not like just showing 5 ads in the app, but more or less like a quite user-specific thing. And that was tough to build locally on the device. So we thought like, how we approach that. And that brings us to act number 2, the backend. So one day, we were in the office again, and Hugo told us, say hi to your new colleague, Brian. He will be working on the backend. So we also found a backend engineer at one point. And of course, if you think back at our architecture, app talks to the database and all the stuff, that was, of course, a bit dangerous situation, and we hope that everything will be fine soon again. But we were optimistic and thought about how can we approach the thing. And yeah, let's start very simple and small, don't overcomplicate things. So just we have an app, we have a backend, how do we do that? And the thing was like, yeah, we just built a route where we say like, give me my offers, and we send over the targeting parameters, like I'm in Mannheim, that's actually where we are located. And also I have loyalty cards of H&M and IKEA. And then the backend tells us back, yeah, here are your custom-made offers only for you that we then show in the app. So that worked great. We could go back to playing table soccer, and everything was awesome till Friday. And Friday was the day where Betty Business normally sent out a push to our users and informed them about a new catalog that became available in the offer section in the app. And I call it the peak season readiness. And that was our peak season is normally then Fridays, where all these little users came and wanted to see their catalogs, and our backend of course crashed because all these it was not designed to build handle so much load, and also like need to compute for each user separately the offers. And we thought, how can we approach this problem? So we went back to the drawing board and thought like, what is wrong here? And we decided to split it up and do the complex things where we compute the user specific things, not on get, but on put. So you upload ahead of time already, I have loyalty cards 1, 2, 3, and I'm in this location and a lot of other things. And once you get the offers, they're already there. So the learnings there is like, try not to compute on get, but always on put. So world was great again. We could also survive Fridays. And then later we met Ralph for the first time. And our backend or some users were just offline that couldn't see the offers. Like if you start our app while there was no internet, the app was just completely, like the offer section was completely empty because we couldn't talk to our backend. So we thought again, how can we solve that? And there's actually a very easy win. And that is about that you add now we are there, add some caching headers to your replies, because that can actually solve already, I say 80% of the cases where a user already opened the app before, he comes back the day after and doesn't have internet, and then still in the cache is the response, and we can show some content. It's maybe not the up-to-date, the latest one, but better to have some content than the none. And that already helped us a lot to build that. And we have one optimization. So this is the next learning, use HTTP caching headers. But there was another issue with our new approach, and that was the mobile data consumption. And if you think about it, the request that we're currently doing for all the offers, it contains all the offers. And it's normally not just 2, as it's depicted here, but like maybe 10, 20, 100. And if you flip just fix a typo in the one of the offers, the user has to download all the offers again and again every time, and that is of course not great for data consumption, especially if you have more content than just these offers like images and so on. So next learning is that it's better to split these big list all responses in smaller sub-resources. So if now, like IKEA is fetched separately from all the offers, and now that helps us to, and you also see there's a revision header in there, a revision part in there, which means you can now use indefinite caching. You can tell, the backend tells with the HTTP cache, you can keep that, you can use that forever. And this is quite nice because then it will not revalidate all the things again. And if you want to invalidate, we just flip in the offer sources part the revision, and then the app goes and downloads the specific thing again. So this brings you already pretty close to like showing content to nearly all the users when they're offline. And we could now say, yeah, we're done with that, awesome, we solved our thing. But it's not all, because there's one more big thing, and that is what we haven't talked about, is what if users can actually modify the data. So far, it was only downloading things from our server, and how do we handle it if actually users can upload or modify the data that we have on the phones. So that brings us to act number 3, or how to slay the monster that mutates. And for this, we want to have a look again at our model that we had, with the user interacts with the app goes to the backend, a response comes back, we have loading spinners. So this is like, I guess, the common strategy, what most apps use, and we want to see what we can do to make that, or improve on top of that. So let's also revisit our other, from the golden age, the model where we had just the app and talking to a database locally, so no loading spinners, no network reliability. How can we make that the database talks to the backend, and that our use cases still just go to the backend to the database level, and later they then are sent to the backend, and we have everything locally on the device. So the rest, or the next part of the presentation, will be about exactly this small dotted arrow between database and backend, and how we handle that. So we approach it again, start with something very small, what you already have, and improve on top of it. So we have here our database. You see, like in the database, we have currently 3 loyalty cards, and they have an ID, always a good idea to have some ID on the database. And how do we handle that? So we need to, like, let's say a user adds a new card. How do we send that to the backend? So how do we upload changes? And the easiest one is just that you add a new column where you say is modified, set it to true, false, and then you remember what you need to upload. And then later, once we used like some work manager nowadays, which then goes through this table and figures out like, this modified, I uploaded, and I'm done with it. There's more to modifying data than adding new ones or updating data, which we actually handle exactly the same. Then the worker comes, figures out there is this modified entry, uploads it, as I said, to the backend, and is done with it. But there's more to it, and that is also that data can also be deleted, of course. Users cannot only add loyalty cards, they also want to delete them. So same solution, new column is deleted. If the user deletes something, we don't really delete it from the database, but just set the flag to true, and then later the worker comes again, figures out there is a deleted card, uploads it to the backend to delete, and then also deletes it from the database. Also, there's this method is called having a tombstone, like around that, you know that this is deleted. That's why the raccoon is sitting in a graveyard. Next one is like we also want to still download changes. Like we don't only want to send it to the server, but also want to download them. So what do we do there? We actually also just add a new column that we call backend revision, where we keep track what the client thinks, what the backend, in which revision, like similar what we had with the offers before. And then we have a route where we ask the backend again, similar to the offers before. Backend, what do you think? What should be the items that I should have locally available? And the backend tells us, yeah, there should be item with ID or loyalty card with ID number 1. It should be in revision this and that, and there's another one. And then later the client, the worker, figures out, yeah, this revision doesn't match. So I need to download this specific loyalty card, and we have it also then offline again. One other part, you might think, there could be also changes to the data on the backend. So far was always the client uploading, downloading things from the backend, but what if the backend has some mechanism to all users get a new loyalty card? How do we distribute that to the users? And for this, we also wanted to have a solution for it. And we then employed this little mailman, which uses FCM, especially for Android, or also WebSockets to distribute like messages. Something changed on the backend, please come and download the latest changes to the client. Putting all these things together, there is a trigger, either a local modification, like the user added a loyalty card that triggers the round trip, or like a FCM message that tells us something changed on the backend. Then we upload all local changes, and only then we download, upload also deletes, of course, and then download all the remote changes on the device. The idea for this way is that if there would be a conflict, like if two clients modify entry concurrently, we would resolve that conflict on the backend or not on the client. Because if you download first and then you figure out there's a conflict, then you need to resolve it there. That's how Git works. If you download something, there's like a merge conflict and you have to resolve it locally. And we opted there to handle it on the server because that is a bit easier. Also, if we have a mistake there, to patch it, and that's our approach. So that is more or less the overall strategy, but we can also dig a bit deeper with act number 4. And the first thing that I need to say is with the database, the structure that I showed you, it was a bit a simplification, maybe a little bit a lie. It is easier to explain it this way because we optimized it. So don't implement it exactly how I presented it so far, and go more with this approach. The big difference there is that, let me change, so that we don't only have loyalty cards in our database. So it's not only loyalty card 1, 2, 3, but all the resources, like also offers, because if you build it once, why use it only for loyalty cards? And you also see in the below one, there's now an offer in this database as well. The next part is the is modified column. And we split that up in two revisions, the local revision and the backend revision. And whenever we update an entry in the database, in the local on the client, we also update the revision, it's more or less a content hash, and later we just compare these two columns where it is different. Has the advantage with the other one, you need to lock the database while you're uploading changes, because if there's a concurrent modification while you're uploading, you could miss one of these updates, so it's better to use these revisions and you don't need to lock the database while you're uploading things. But yeah. Other part is the is deleted flag. You can also build that then with the local hash and also like just setting your content to null. That is how we replace this column and makes things a bit easier. So like not a big lie, it's just some optimizations that you should use. And also about pushing changes, the little mailman nowadays, he has grown up and he's not delivering packages anymore, but whole parcels. Like before it was like the little mail about something changed, and now he comes with a whole box and also the changes already in the box. So like we don't, you can also with FCM, you can also ship data to the clients, and that makes it very nice because on the one hand, you have now the data in there, and also what FCM offers is topic pushes. So like you sent, we put all our clients in one topic, we push, if you have some global resources, we push that, and with one backend request, you distribute like to millions of devices with one backend request, which is quite awesome and saves, for example, a lot of cost too, and also makes it nice for the users in the end, because they have then up-to-date data when they launch the app the next time. So we come to the last, or nearly the last part, and that is how does it actually work nowadays as an engineer when I work with these kind of things. And for this, I want to go back to digitizing a loyalty card, how we would build it nowadays, and not with these loading spinners and all the things. And that we normally start, if we build a new feature, we define a schema. The interesting part with that is normally, I think, or at least for us, before it was often like the backend told you, we have a new specification, you can implement it there, this is the route, this is like what you're gonna do, this is the spec that we built you. But for us nowadays, it's like owned resource that is owned by the Android, iOS, and backend engineers, and we sit together and write a specification file. We currently use JSON schema, but it could be whatever, like just what was the easiest for us. And you see, like we, for example, define a loyalty card should be an object, has some required properties. One of these required properties is the number of the loyalty card, and it's a type string. And if you think what would normally happen in the past when you had your endpoints defined, and what did you do as an Android engineer? Or let me ask, what do you think, who is this, and what is this person doing? So it's me, or I guess most of the Android engineers. And what is he doing? Waiting for the backend endpoint to be implemented to also start implementing things. I hope you can see a bit the resemblance with Mr. Bean waiting in the in the field. So the nice part is now, if we have this schema, what we actually use it for is that we generate a lot of things. And the first one is we generate the DTOs, and the DTOs for the Android client, for the iOS client, and for the backend. We also auto-generate the backend endpoints because it's like a fixed defined way how the backend, the clients interact with the backend. So it's always the same. We just implement it again. Auto-generate all the things, and that means you don't have to wait. Like once you have the schema worked out, it's already running on the backend. You can even interact with it with curl. Like the backend has not implemented their things yet, but you can just play backend and interact with curl with this kind of endpoint and drive already the process. And also serialization logic that we run on the clients is also auto-generated. And last but not least, the documentation, which is also nice that all of these kind of things, once you have the schema file done, it's all there. So for a mobile client, what does that mean? How do we work with this kind of protocol? And for this, we have one thing that we call the synced data store, or repository, maybe in the more Android-y terms, where I would put it. And it has like the first method is give me all the things. And you put in like the path like /loyalty cards, for example. So give me all the loyalty cards that this user has. And the data mapper is the thing that I told you is the auto-generated part that maps, like, can deserialize the data, because this protocol is like, it doesn't care if it's JSON or images. It just is binary data that lives in this database, and then you need to specify how it should be deserialized. The next part is I want to have one specific resource out of the thing. So one loyalty card, not all of them, but one specific one. And the next method is I want to write or update or create a new loyalty card or whatever resource you want to have in this synced data store. And the last one is I want to also delete some entries. And that is exactly the things what we saw before, which then go into this database table, set some flags or do some things, and then trigger the work to synchronize it with the backend. If we now go, what does that mean, how we built the app? Is like, let's say we want to implement this screen that shows you all the loyalty cards that you have in the app. So the first thing we want to check is the cards repository, which is such a synced repository. And I use that a notation from RxJava. I don't know if you're familiar with it. It's like a timeline, and the bubbles that are emitted are more or less over time. And the first emit was like, this user has 2 loyalty cards. So that was like the get all route, more or less. Similarly, on the screen, you also see down there, there's also offers, how many offers are currently unread from this user. So we will also ask the offers repository, what are the offers that this user should have visible in the app. Then we go to the more view model layer, where we then have a combined latest. That's like, I think, the most used function in our whole app, combine latest, just combining things together and bringing it up. And in this case, it computes the UI state, and that then leads to what we show in the app. So let's think user now added a new loyalty card, and this one goes into the cards repository. Cards repository emits a new list, this time 3 loyalty cards, combine latest, does its magic, and computes a new UI state, and we see the 3 loyalty cards directly in the app. So that's already quite nice, because it, I guess most of you know, like the data flow that should be like in one direction, and this helps there to build it very easily, and it's on the device, so you don't really have to have loading spinners, because once you added it, the thing will emit in like a few milliseconds. Maybe you still want to show some small loading spinner, but maybe after 16 to 32 milliseconds, you should have the update on the UI already. And the really nice part is, I told you that it will automatically upload it to the backend, and the backend will send FCM push messages to other devices that have this. So how it is, if you have a second device B, and that means like this loyalty card not only goes in your local repository, but also in the ones of your other devices. And there the same process happens again. The card repo emits a new list of loyalty cards. This computes a new UI state, and you directly see on the second phone also the cards appearing. And that's quite nice that you have now, like if you implemented it once, like we did now, the nice part is you can reuse it for all your features you have, and you have like the automatic synchronization between devices, distribution of updates via FCM, and all these things you can optimize for, which is pretty nice. We also very brief look at how the backend works with these kind of things. So I told you the backend endpoints are auto-generated, and we also sometimes want to have some logic there. For example, that let's say they want to compute all the loyalty, the list of or the number of loyalty cards that were ever added to our app or by all the users. And there they normally work with queues where all the operations go in. So the backend already took the new loyalty card in, and then they have workers like these guys that scan all the loyalty cards or count them up, and then we have a final count. Or they could also say, they validate that these loyalty cards are legit, and then they throw away some that are not. So this is also quite nice for the backend, because with these queues, they can scale quite easily. So like at night when there are less users, some of these raccoons can also have a break, and during day we can hire a few more to handle all the workload they have to face. And it's also more resilient, because like the backend endpoint already took in the new loyalty card, and even if then currently nobody's working there, the reply will come a little bit later, but it doesn't really matter because the app is offline capable. So even if the reply takes longer, we don't really care about that. To the end, the summary. I hope that I could take away a bit the fear from Ralph, that you also can become friends, and that you also see the benefits of building offline first apps. One big point is the user experience, as I mentioned in the beginning, the developer experience. It's nice to build screen flows without caring about missing network and how the user should be able to retry that. It can also save you cost, and it's also not rocket science. Thank you.